1.7 Programmable logic devices. There are a wide variety of ICs that can have their logic function programmed into them after they are manufactured. Most of these devices use technology that also allows the function to be reprogrammed, which means that if you find a bug in your design, you may be able to fix it without physically replacing or rewiring the device. In this book, we'll frequently refer to the design opportunities and methods for such devices. Historically, programmable logic arrays, PLAS, were the first programmable logic devices. PLAS contained a two-level structure of AND and OR gates with user-programmable connections. Using this structure, a designer could accommodate any logic function up to a certain level of complexity using the well-known theory of logic synthesis and minimization that we'll present in Chapter 4. PLA structure was enhanced and PLA costs were reduced with the introduction of programmable array logic (PAL) devices. Today, such devices are generically called programmable logic devices (PLDs) and are the AMSI of the programmable logic industry. We'll have a lot to say about PLD architecture and technology in sections 5.3 and 8.3. The ever-increasing capacity of integrated circuits created an opportunity for IC manufacturers to design larger PLDs for larger digital design applications. However, for technical reasons that we'll discuss in CPLDs, the basic two-level and OR structure of PLDs could not be scaled to larger sizes. Instead, IC manufacturers devised complex CPLD architectures to achieve the required scale. A typical CPLD is merely a collection of multiple PLDs and an interconnection structure, all on the same chip. In addition to the individual PLDs, the on-chip interconnection structure is also programmable, providing a rich variety of design possibilities. CPLDs can be scaled to larger sizes by increasing the number of individual PLDs and the richness of the interconnection structure on the CPLD chip. At about the same time that CPLDs were being invented, other IC manufacturers took a different approach to scaling the size of programmable logic chips. Compared to a CPLD, a field programmable gate arrays (FPGA) contains a much larger number of smaller individual logic blocks and provides a large distributed interconnection structure that dominates the entire chip. Figure 1-6 illustrates the difference between the two chip design approaches. Proponents of one approach or the other used to get into religious arguments over which way was better, but the largest manufacturer of large programmable logic devices, Xilinx Corporation, acknowledges that there is a place for both approaches and manufactures both types of devices. What's more important than chip architecture is that both approaches support a style of design in which products can be moved from design concept to prototype and production in a very period of time. Short time. Also important in achieving short time to market for all kinds of PLD-based products is the use of HDLs in their design. Languages like Able and VHDL, and their accompanying software tools, allow a design to be compiled, synthesized, and downloaded into a PLD, CPLD, or FPGA literally in minutes. The power of highly structured, hierarchical languages like VHDL is especially important in helping designers utilize the hundreds of thousands or millions of gates that are provided in the largest CPLDs and FPGAs.